Hello everyone, welcome to the video on finding the 6 trig functions in the unit circle. This will be helpful if you have a unit circle on hand. I'll just kind of reference this one here while I do this. So you should have all the radian measures and degree measures filled in, or if not filled in, at least in your head, or maybe the unit circle handy so that you can have something visual as an aid. All right, I'm going to find the sine at pi over 2. Remember that the sine of any function is going to be the ratio of the opposite over the hypotenuse. When we're talking about the unit circle, what that means for us is that I've got some angle here. Let's say it's a 30-degree angle. That when I talk about the side opposite, I'm always talking about the y value. And when I talk about the side adjacent, I'm always talking about the x value. So from now on, anytime you see y, you should be thinking, okay, what's the y value? Anytime you see cosine, you should be thinking, okay, what's the x value? Because the ratio for the cosine of any angle is the adjacent over the hypotenuse. And then, of course, for tangent of any angle, the ratio is opposite over adjacent. Opposite being the y value, adjacent being the x value. So anytime you see tangent, you're thinking y over x. Okay, we'll get to reciprocal trig functions in a moment. So first, let's find the sine at pi over 2. Here's pi over 2. The coordinate there is 0, 1. So I'm looking for the y value there, which is 1. Let's skip cotangent for now, and we'll talk about the cosine at negative 270. Negative 270 is a rotation of 270 degrees. Positive rotations going counterclockwise, negative rotations going clockwise. So what I'm interested in here is going negative 270 degrees. That would be right here. That gets me to pi over 2, or 90. Okay, so if I'm going negative 270 and I want to find the cosine there, the cosine is the x value. At the point 0, 1, that's 0. All right, now let's look at the tangent at pi. Here's pi, right? At the point negative 1, 0. And the tangent there is the y value, which is 0, over the x value, which is negative 1. And that is equal to 0. Okay, so now we're talking about reference angles. 135 degrees is an angle in the unit circle. It's not a good drawing, sorry. 135 degrees lives over here. I'll just work in purple. In the unit circle, right, in quadrant 2, and I want to find its reference angle. Well, 135 is a reference angle of 45 degrees, right? It's in the 45-degree family of triangles. It happens to be at 3 pi over 4. That wasn't asked for, but just for reference, right? It's a 3 pi over 4 situation. Okay, and if we sketch it, here's what it would look like. Something roughly like that would be 135 degrees, right? A rotation from the x-axis, 135 degrees. Its reference angle, meaning what does it take to get down to the x-axis, is 45. It's all based on that 45, 45, 90 triangle. Okay, now at 7 pi over 12, we'll do this one in green. At 7 pi over 12, well, that's not on the unit circle, but I can figure out what that measure is. 7 times 180 divided by 12. All right, let's see. I'm going to use the calculator for this, and bear with me. 7 times 180 is 1260 divided by 12, and the answer is 105 degrees. Okay, 105 degrees, not on the unit circle, but that doesn't matter. 105-degree rotation is just a little bit past 90, right? So this would be 105 degrees. Now, to figure out what the reference angle is, I take 180 minus 105, and I get a reference angle of 75 degrees. Okay, let's skip 405, negative 405, and let's do 5 pi over 6. We'll do that in red. 5 pi over 6 is on the unit circle. That exists at 5 times 30. That's 150 degrees. Not necessary to know that, but sometimes it helps me to think in terms of degrees. Okay, now I'm making a rotation of 150 degrees. There's what that looks like. The reference angle here is 180 minus 150, and so the reference angle is going to be 30 degrees. So any sine, cosine, or tangent that question that I have to answer, any trig question that I have to answer, is based on the coordinates for a 30-degree triangle, which is negative square root of 3 over 2, comma, positive 1/2. Remember, we're sitting in quadrant 2 here in the unit circle. Okay, so now we are talking about finding the trig values in the unit circle. Let's find the cosine at 4 pi over 3. Let's do that. We'll just do that in blue. So the cosine at 4 pi over 3, you can use the circle if you need to. 4 pi over 3, that's at 240 degrees. If working in degrees helps you, great. If it doesn't, then just work in radians. All right, so 240. So I always like to draw a little picture here. 240 would be right here. The reference angle is 60 degrees. That's a 60. So the coordinate for that point would be negative 1/2, comma, negative square root of 3 over 2. So the cosine there, the x value in other words, is negative 1/2. All right, let's look at the sine at 3 pi over 4. All right, 3 pi over 4, that's 135 degrees. I'm in quadrant 2. The sine is going to be positive. It's a 45-degree reference angle, and so it's the square root of 2 over 2. Okay, we'll skip cosecant for now. Well, actually we won't. Yeah, we will because it's 390. Let's just do sine, cosine, tangent for now. All right, at 11 pi over 6, that's 330 degrees. And the tangent there, I need to draw a picture, little picture for this. 330, that's a reference angle of 30 degrees. The coordinate there is square root of 3 over 2, comma, negative 1/2. This is all coming from the unit circle. All right, now tangent is y over x. This might involve a little bit of math here. The y value is negative 1/2 over the square root of 3 over 2. Okay, that is the correct answer, but it is not in the correct form. Whenever I have a fraction divided by a fraction, I need to fix it. I need to make it a proper, instead of improper fraction, I need to do the keep. So I'm going to keep the numerator. I'm going to change the operation from division to multiplication, and then I'm going to flip the denominator over. So I'm going to multiply the numerator times the reciprocal of the denominator. And what I get is negative 2 over 2 square roots of 3. Well, I can't have that. There's one more step here. I need to now rationalize the denominator because I can't have an irrational number in the denominator. So I take negative 2 over 2 square roots of 3. And yes, if you're thinking, could I simplify that? Yes, you can. I'm just showing you all of the work and then the simplification at the end. Square root of 3. So nothing's disappearing through reducing or simplifying. Now I'm rationalizing by multiplying by a fraction equivalent to 1 that will get rid of the radical signs in the denominator. So I end up with negative 2 square roots of 3 over 2 times 3. The 2's can now cancel, and what you end up with as a result is negative square root of 3 over 3. So that is the answer, final answer, to the tangent at 11 pi over 6.